So my name is Victor Cuascut. I am the Director of Technology and the lead cloud architect at Clear. Clear, for those of you that don't know, is a biometric identity company. What we do is we take your biometrics, so your face, your fingers, your iris, and we identify you. We figure out who you are with accuracy, and we're able to identify you and put you in places like airports, currently in ballparks, in stadiums, and even commerce. So GitOps is a term coined by Weaveworks. And what it actually means is operations by pull requests. Right? The latest buzzword inside the DevOps culture that, that everyone is kind of using. But what it actually means is it's actually pulling in what DevOps has been trying to do for the past 10 years. Right? It pulls in automation, infrastructure as code, and tries to define it inside a centralized location. Right? How is your infrastructure in totality defined as code? Not just a singularized application, not just one web instance or one resource inside AWS, but how is the totality of your infrastructure, multiple accounts, multiple regions defined as code? So why should we even care, right? So infrastructure as code is something that the cloud infrastructure, the DevOps community has been basically striving for the past decade, right? Make things easily deployable, reliable, continuous, right? Basically build out the entire state of your infrastructure in a singularized repository, right? That's where the whole Git mindset comes in. And operationally do your entire infrastructure as code, right? Do pull requests. The same way that you would build a web service will be the same way that we define our infrastructure. And if we leverage Git this entire time, we are actually going to pull in a lot of the auditability and the consistency that Git provides just by default. So we get versioned infrastructure. We get audit trails. We get to roll back our infrastructure on the fly just by using Git as a product, nothing else. So you can't actually do any of this unless you actually build infrastructure as code, right? And at Clear, we leverage Terraform, all right? And with Terraform, you're able to build out your entire infrastructure, define it within resources, and then push it out to your architecture, right? So not only are you able to define resources as we do in Clear, but also third parties. So, how do we automate things like connecting to PagerDuty or talking to Datadog or something like that? So that could all be defined as code via Terraform. If you use Terraform in the past, you have a good concept of what modules actually are. So modules actually define what a base infrastructure should look like. You tie in compliances, you take a structured set of code for what an infrastructure will look like, and you define it as a module. I take that one step further and actually split it out into two separate modules. Right? We have root modules, and then we have application modules. So root modules, the way that I'm defining is what most of you would think about as modules to begin with. Right? It is a set of code for Terraform that defines an infrastructure. It actually, you built in compliances, you take a massive, complex architecture, and you define it into a singularized module. Application modules, on the other hand, are much less complex. So you actually take an application which would reference, in many cases, root modules, and leverage it side by side with your application. So if you, say, have a web instance that needs a S3 bucket and maybe some IAM roles, you can actually define it inside, side by side with your application, and reference root modules that actually build out the compliances. So your S3 bucket is defined by your application, but because of the root module and the compliances around the root module, you get to define that it must have encryption at rest. It must be private facing. It cannot be publicly facing. So you're able to define multiple application modes in that case. But if you actually have you actually use modules, then you start figuring out how good is your CI game. This actually blows a lot of infrastructure guys' minds in most cases, because you start thinking like a developer. Infrastructure is not this massive piece of hardware that it once was, is defined as hardware. Now you have a person that could write a set of code, and the same engineer could write 10 lines of code and deploy 100 services, 100 different instances in a push of a button. But you could only do that if you know what you're doing and you are testing out your applications. So the whole GitOps mindset means that you are doing pull requests and you're actually committing the infrastructure inside Git repositories. So for the centralized modules, you're actually able to create feature branches, do a pull request, test out your infrastructure, get it approved, and then get it merged. You actually, for your application module, you do exactly the same thing, but you do it side by side with your application. Right? So the same way that you're testing your Maven build, it would be the same way that you would test your actual Terraform deployments and make sure everything is working cohesively. So on a side note, right? If you are doing this, the first thing you're going to want to do is standardize how you build, test, and deploy. So the way that we're pushing for in Clear is building a build harness. So the originators of the build harness, which I forked, and you can see it inside my GitHub repository, is a company called Cloud Posse. Great name, right? But what it is actually a set of make files. And that is actually inside a separate repository and standardizes the entire process for deployments. So you have a set of make files inside a Git repository. And for your application, when you want to run something, you actually just run make test, make plan, make deploy. That actually pulls from a Git repository, so it standardizes the build and deploys it locally. You can see a list of a whole bunch of things that you want to deploy. How does this make things easier? So not only are you all building the same way, so as a developer, an infrastructure developer, you're building your testing exactly the same way that your CI pipelines will be building, testing, and deploying. But the next time you hire a new engineer, it's much easier to tell them to do build Terraform tests versus learn how to run test kitchen or learn this new pattern on infrastructure. Talking about testing. Test your infrastructure. You actually cannot have infrastructure as code as a modularized infrastructure that is consistently deployed unless you test everything that you're doing. Testing is also very foreign to many of the infrastructure developers nowadays. But it's actually very, very simple. So inside the build, if you clone the repo, the build harness, actually make it very, very simple. So you build valid Terraform, make sure everything works, and using the top command, you actually could just deploy the infrastructure into an infrastructure testing environment, and then generate a whole bunch of test suites by default, right? And what you want to do by doing that is define a contract. You want to define a contract that anybody that's using your application would be able to abide by. So if you're building a module for an S3 module, and you would say that by using my module, I am guaranteeing that this will always launch, it will always be encrypted, it will always be in a private zone. And if it's not, that's on me. But by building out test suites and building out that contract, you're actually able to define that and test it continuously inside your CI pipelines. Once you get into the GitOps world, what it means is define your entire infrastructure as a set of code inside a defined repository. So the way that I see that is build a manifest. right? Understand what is inside your environment at all times, right? I should be able to, at any moment of the day, be able to say, in production, I have application X, Y, and Z. I have compliances, module X, Y, and Z, and they are deployed, they are working, and they are consistent. You want to do that across all your environments. It gets simple when you have one environment, but much more complicated when you're trying to build multiple environments and distribute it across all over your business. Here, you're actually building a single source of truth. You have a definition, a single YAML file, stored inside a repository that has every single application you have in a list, right? And using the build harness that I had before, simply plan it and apply it. Test out, make sure everything is working. You now guarantee that everything is working appropriately because you tested all the modules in the first place. And now with a plan and apply, you're able to then deploy consistently within your architecture. Now, this is a singularized repo. So I put together a demo that you could find inside my GitHub page that basically defines the entire manifest project as well as multiple modules that you could deploy within a single environment. If you look at inside the Terraform GitOps demo, you're able to see a configuration file. So say we want to build out a brand new infrastructure. We want to deploy it. We want to define everything that we had. And we want to make sure everything is running appropriately, right? So this is extremely simple, but you could see very easily the business unit, right? The business that you're actually running in, the account that you are defining, and the region you want to deploy, right? You could, it's just a list. So you could add as many regions as you want, as many accounts as you would need inside that single list and deploy it into the architecture. So everything here is written as code, and everything references the root or the application modules that we talked about earlier. So if you wanted to define a new VPC, as defined over here, a platform VPC, you're able to then define it relatively easily by just defining a single module. So if you look up at the top, one of the good consistent ways to do things is always back your stuff up into S3, right? Keep your state, make sure you have your state, don't lose your state. But the secondary provider, where it says provider and allowed account IDs, is a great way when you're actually defining things in an automated fashion. You actually define the account that you want to deploy in. And if that account does not meet where you're deploying, it just won't run, right? Safeguard all your deployments. But inside the module itself, you're now building source that references the root modules that you have tested already in the past. So right now I'm referencing master, but you could pin it. You could do whatever you need to do to reference the modules in the back, right? And if you look at the configuration file, go back to the configuration file, defining, saying that I have some sort of compliance needs. Over here, I have a global compliance that has nothing to do with a specific VPC. Config baseline, make sure that that's put everywhere. And then start up a Route 53, a VPC and a Route 53, all right, relatively easily. So that could actually be run very quickly and easily by running make manifest apply. So you can see here, and I'm doing this without any of the CI stuff, so you guys can see what actually happens. But you actually just define a few variables inside the make file. The actual code that actually deploys this is actually generated inside a make file, inside a Docker image, which is referenced inside the build harness repository in GitHub. But it just runs validates the business that it's running. I'm saying I want to run the development account, and I want to run everything. I want to give me everything that's inside this config and run it inside US East. Or at least give me just the US East portion. I could also put all inside there as well. But running this will then iterate through every single one of the configs inside this manifest and make sure that it is working, it is validated and going through. Now, the way that you would run this inside a productionized setting, and which I'm bypassing here, is you would actually do a pull request. Again, everything here is pull request as code, right? So you actually do a pull request. The pull request will actually run a plan and validate your entire infrastructure. And anything that's different will actually output. So you could then validate it and make sure that it is all up to snuff and everything is good, and then push it out to be merged. So approve it to be merged, right? Once that is validated and merged, it would go ahead and make sure that everything looks good. So in this case, I actually built these baselines, right? Make sure everything was actually running and installed. So this is where a common infrastructure is already built out. But let's say I wanted to build out a brand new VPC, right? And I wanted to throw in, say, a web instance on it. What do you have to do, right? Modules have already been tested. Everything is working. Everything is good. So the only thing I have to do is add new configuration values here, all right? So uncomment these out. But now I'm saying, give me a new VPC. And this VPC does not exist. This is not inside the current infrastructure, the test infrastructure that I put in place. But you're able to define a brand new VPC and then give me a Fargate instance. All right? So what I'm going to do here is I'm actually going to commit this. I'm going to merge it into my GitHub repository. And let's see if the CI continuously just deploys it into our infrastructure. I'm going to, again, bypass the whole pull request model and just say I approve it. But I'm going to merge this in. Now, with a simple git push, I said I want this thing to be deployed into my infrastructure. It doesn't know anything about the other modules except that I say I defined it and I put configuration values, right? If I go to Travis now, it should pick up that the GitOps demo just got committed to. So once we actually have the GitOps demo committed to, what it's going to do is, and this is Travis because it integrates easily with GitHub, but you could run it on any type of platform, any CI/CD deployment tool. What it's going to do is actually download a base Docker image. It's actually going to reach out into Git and pull the build harness, and that is defined at that state, and deploy it into the Docker. It's then going to deploy the code that is specifically for the deploy manifest, so to actually deploy the infrastructure to the rest of the infrastructure, the rest of the organization, and start working on iterating through the list. Now, in most cases, this will not do anything. Everything will already be done. But since we made several changes, it should actually find the new VPC and the ECS instance and actually deploy it continuously. So, now, while this runs through, one of the other things that we would then do is have another job. Have a job that's running on a continuous timer that is just running a plan, right? So with the deploy manifest, you're actually able to figure out if there's any changes from your current infrastructure that's not defined inside Git. And that's running continuously. We run that currently every hour and just validate that your infrastructure is up to snuff and nobody's actually going in and tinkering with it. And if there's any issues, it would actually send out an email alert and say somebody's actually touching the environment that they shouldn't. But what we would then do is actually remove all access from anybody, any administrator actually running production, right? Inside this model, there's no need to actually have administrative access. Those are only for break glass solutions. All right. So we'll go back to the actual demo part so we can see that actually worked. Now that we're able to define everything as code, we're able to build out a standardized manifest and dictate that everything that we have documented is actually what's in production, and there's no actual drift, right? Now we actually understand everything that's in there. We have compliances around, we know what's actually being deployed, and at any moment we could look at rollback based on Docker commit versions. We know who's running what, we know how it's being run, and we know the last person to do a commit if there was any issues. So what does that mean for scaling, right? So this is a infrastructure that many people here are aware of, right? A singular AWS account, a singular VPC, and maybe if you want to get fancy, you have multiple availability zones, right? This is the typical first infrastructure setup, right? So inside the design that I showed you with the configuration file, this is relatively easy, right? But now if you want to actually expand that, right? So in Clear, we actually went from having, within the past 4 years, growing our infrastructure about 15 times its size with the amount of traffic that we've been getting, which has been massive, right? So you could go from something like this, which is relatively simplistic, to an infrastructure that is now multi-business unit, multi-region, multi-account, spanning the globe if you want to. And what does that mean from a manifest perspective? And from my perspective, it's just configuration values, right? Add more lines to that config. Add another repo for another business unit so you could build out separation. But it's just configs, right? You get to define the entire thing. This whole unit is just a YAML file. So, final thoughts. Standardize all your deployments, right? Standardize your deployment patterns. The same way that you are testing should be the same way that everyone on your team is testing, should be the same way that your CI and your CD tools are deploying. Automate all the things, right? Anything that could be defined as code should be defined as code. If it's not, figure out how to define it as code, right? Automate everything. You are not able to build out an infrastructure that is repeatable unless it's automatable, right? Test your infrastructure, right? You cannot guarantee that the things that you're putting into production are going to work 100% of the time if you have 17 infrastructure engineers all developing code, all pushing in without testing your code, right? Make sure everything is tested, validated, and you're building contracts, and you're abiding by those contracts. And manage everything through a pipeline. Put it through a pipeline, make sure everything is working, and don't deploy anything by hand. Make sure everything is consistent and is validated through the pipeline. And then build a single source of truth. Once you are in a position where everything is defined as code, now define it as a singular configuration. Not only define your application and your infrastructure as code, but define your entirety of your business as code. So I put in a few resource links here. Some of the stuff that the original build harness was actually, like I mentioned before, was created by a company called Cloud Posse. But not only did they build the build harness, but they actually had very good Terraform modules, which I was able to kind of copy paste into the build harness and deploy it with the manifest with a few configuration value changes. Now, the whole mentality around GitOps. So Weaveworks has tons of talks around GitOps, right? They coined the phrase, they defined what this actually means, and they have been pushing towards a Kubernetes infrastructure. I want to say a level on top of that and actually define how the infrastructure is made before you get into the Kubernetes world. But with Weaveworks, you're actually able to define the entirety of your Dockerized infrastructure as well with a GitOps mindset. And then the stuff on the bottom is some of the stuff that I actually went through and kind of defined as I was building this out, right? The testing suites, the Terraform model on how they actually define the separation between accounts and environments, as well as Atlantis, which is also a very good tool to actually deploy your Terraform via GitOps pull request models as well. So while this is going through, let's see if this actually deployed. So there it goes, creating. So just by pushing it in, you're able to build out your entire infrastructure, make sure that it's running inside the proper environment, and actually build it out continuously inside your environment. But define everything as code, define your stuff as in GitOps best practices, and you can continuously just run your environment nonstop. Thank you.